Thanks everyone for joining us today. We are very excited to bring this webinar to you. As I mentioned, if you were here for the audio check, my name is Katie Peach, and I am the domain leader for advanced and potable reuse for Veolia Water Technologies and Solutions. And I'm going to be your moderator for this session today. If you do have any questions, as mentioned, we'll answer them at the end of the speakers. But feel free to put them in the chat at any point, and they'll be there for when we get to that. So without further ado, I'll introduce our speakers. So we're going to, the first person we'll hear from is Leanna van der Zalm, who is part of the process engineering team at Veolia Water Technologies and Solutions, specializing in anaerobic digestion technologies. She completed her degree at the University of Guelph in biological engineering, focusing on bioreactor design. Her passion for sustainability is demonstrated in her work at AWTF through projects that contribute to waste reduction, renewable energy production, clean water, and lower greenhouse gas emissions. Our second speaker today, that we're very excited to have here with us as well, is Alex Waite, who is the supervising civil engineer with the city of Santa Monica. In this role, he oversees the design, construction, and optimization of the city's drinking water, wastewater, and recycled water systems to implement the city's goal of water self-sufficiency. Alex is a registered professional engineer in California and is also the co-chair for the California-Nevada AWWA Recycled Water and Desalination Committee, and the vice president of the Water Reuse California Los Angeles chapter. So with that, big thanks to our speakers for being here. And we're going to dive right in and talk to you about how Veolia Solutions enable customers to achieve sustainability goals. So with that, I will pass things over to Leanna.
All right, so I will first give a quick agenda of what we will be talking about today. First, Alex will go over the project for City of Santa Monica, which is an indirect potable reuse project. I will then go over VWTS's greenhouse gas quantification methodology. And then I will go through 3 projects that we completed this quantification method on, including the City of Santa Monica, a food and beverage water reuse project, and an anaerobic digestion facility project. We will then go to our questions. So I'd like to pass it over to Alex, next slide, please. So for sustainability goals, which is the focus of this presentation, as climate change becomes more apparent in everyday life, changes need to be made on many different levels to ensure we start setting and reaching sustainability goals. Emission reductions, water conservation, and waste reduction all have direct impact on a project's quantification of sustainability. There are many direct and indirect impacts that need to be considered in this. By companies focusing on hitting their sustainability goals, it will allow us to monitor our impacts and hopefully reduce the evident issues that climate change is causing. Now I'd like to pass it over to Alex.
Great, thank you so much, Leanna. So for those who are not familiar with the city of Santa Monica, we're a very small city. We're only 9 square miles within Los Angeles County. We're sitting right on the edge of the Pacific Ocean. So we're fully urbanized, fully built out. There's not a whole lot of space for new facilities. We serve about 93,000 residents and about 18,000 service connections, producing about 9 million gallons per day of high quality drinking water. We also have a very small recycled water system. This is for stormwater management and urban runoff as a best management practice. But you'll see in the next few slides how we're increasing that capacity for recycled water and then reducing our overall imported water that we use. So in 2018, the City of Santa Monica City Council approved an update to our Sustainable Water Master Plan. This master plan identified several components for the city to meet its self-sufficiency targets of being completely reliant on local supplies and reducing the amount of imported water that we receive from the Metropolitan Water District of Southern California. So there's several different drivers for this decision, but some of these are included in this first bullet point about creating a diverse and sustainable and drought resilient water supply to support the Santa Monica community when imported water supplies carry a much higher energy and carbon footprint, and that the city is facing increased climate-based related hazards that we need to identify adaptation measures to achieve. And so in 2019, the city also produced the Climate Action and Adaptation Plan This was a holistic view at all the city's infrastructure, including the water system. And through the Climate Action and Adaptation Plan and Sustainable Water Master Plan, we're now well on our way to reducing the city's carbon footprint significantly and being water self-sufficient by the end of this year. So one of the last points I want to point, one of the last pieces I wanted to discuss here is with respect to cost, because that's always a significant driver. And one of the things that we found as we tried to seek water self-sufficiency and resiliency, as well as reducing our carbon footprint, is that it actually equates to long-term cost benefit for our ratepayers as well. So by folding in these different projects, including the Sustainable Water Infrastructure Project, which I'll touch on soon, we're actually seeing a net decrease in the overall cost compared to imported water. So there is an advantage to seeking these carbon footprint reductions as well. So this is a schematic of the city's current infrastructure circa earlier this year, where we are receiving about 40% of our overall water supply from imported water and about 60% from locally produced groundwater sources. And this is a very linear track. We're taking water, it's being used, and now it's being sent to the City of Los Angeles Hyperion Water Reclamation Plant. And then I mentioned our small recycled water system. So this is our Santa Monica Urban Runoff Recycling Facility, which takes stormwater and urban runoff and treats it for non-potable recycled water opportunities like irrigation and toilet flushing. And this is a very small system, but you'll see in the next slide what we've done to now close the loop on the one water cycle. So there are three different components that were identified as part of the Sustainable Water Master Plan. The first is conservation. So just by utilizing a very rigorous conservation plan, we're able to reduce our overall water consumption from 2015 by about 20%. And we are investigating additional opportunities to be even more aggressive on conservation. And then the next two components are folded into our overall capital improvement program. So these two represent the largest piece of our $200 million CIP budget. The component two is our alternative water supply. So this involves the Sustainable Water Infrastructure Project, the installation of a brand new advanced water treatment facility, and upgrades to our existing SMRF facility. With these two facilities together, we're able to produce about 1.5 million gallons per day of advanced treated recycled water that can continue to be used for non-potable applications, but also meet the strict California regulations for groundwater augmentation. So we're taking that water, about 1 million gallons, injecting that into our groundwater aquifer, and then reusing that into our component three, the new local groundwater, to be used for drinking water applications. Okay, so let's dive into the SWIP project, the Sustainable Water Infrastructure Project. So there's the two different facilities that I mentioned. The first, the Advanced Water Treatment Facility. So this is a brand new facility that's able to take raw wastewater and up to 30% blend of stormwater and urban runoff supplies to then treat this to the Title 22 per the California Code of Regulations requirements for groundwater augmentation. And then coupled with this is the SMRF facility, which is taking that stormwater, urban runoff, as well as a brackish groundwater supply, treating that through several different multivariate treatment processes to meet the diluent water requirements per Title 22 under the California Code of Regulations. So both of them together meet in our purple pipe system that then is served for those non-potable and the groundwater augmentation. So there's a lot of different benefits related to the SWIP. I'll just touch on a couple of these bullet points. So the first two are related to the overall beach water quality. So this project was actually originally envisioned as solely a cleanup and mitigation activity to make sure that Santa Monica Bay was not impacted with pollutants. And over time, the project actually morphed to include a lot more different components to take in the raw wastewater, the brackish water, and those different sources. So with those additional opportunities, this project can also provide a drought resilient water supply and diversify the city's overall water supply portfolio. And it's increasing our recycled water production and augmenting that local groundwater supply so that way we don't have to import so much water from the Metropolitan Water District. So the SWIP Advanced Water Treatment Facility is a multivariate treatment process that you can see here in this schematic. But the two pieces I really want to highlight that were first for California potable reuse facilities, this is the first facility to receive log removal credits for virus, crypto, and giardia for a membrane biological reactor, which is actually the ZWeed product provided by Veolia, as well as the cartridge filter. So this is the first two systems of this type to be granted log removal credits in California. And then touching on the Smurf facility, so this is producing that up to 500 acre-feet per year of that Title 22 diluent water source. And with the addition of a new reverse osmosis system to this treatment train, this will now be the first stormwater direct injection project in California, which has typically been permitted as more like a spreading basin. But as I mentioned, we don't have the land, we don't have the opportunity to do spreading basin, so we had to go for something a little more direct. All right, so now I want to show you some really cool pictures of the facility. So this is looking from one of our parking structures at what looks like a parking lot. And I know it's like, wait a minute, you're just talking about advanced water treatment facility, where's the plant, right? Well, on the next slide, you'll see what it looks like below the parking lot. So underneath that parking lot is our advanced water treatment facility. This is about 20 feet below the ground surface, and our biological treatment basins actually extend to a depth of 45 feet below the ground surface. So from down here, you can see our various treatment processes. So the cartridge filters in the foreground with the RO system behind it and the UV AOP way in the back. And then on this side, this is our quote unquote dirty process area. This is where the raw water supplies are coming in from the raw wastewater and stormwater urban runoff, is then treated through a biological treatment process, and then the membrane separation process, which is shown in the foreground. And finally, here's a picture of that MBR cassette being loaded in, so you could see how this would be accomplished from the surface level down into the operating floor. Great. So with that, I'm going to pass it back to Leanna to talk about the greenhouse gas inventory assessment.
All right, thank you, Alex. So first I will go through the reasoning for these assessments. So climate change has a measurable impact on the environment, including climate changes such as increased temperature, fluctuations in precipitation, and sea level rises. Public and private sector entities are working to adapt to these impacts and to reduce emissions in order to lessen the severity over time. For Santa Monica and many other municipalities, these climate changes can lead to local hazards such as increased drought and flooding, which can have a direct impact on civilians through water shortages, increased utility rates, crop losses, and property losses, among many other things. Among tracking the previously discussed local impact climate changes can have on a community, municipalities can also track their greenhouse gas emissions to see how much their current facilities could be contributing to these local impacts. Municipalities can then set goals to reduce these emissions over time based on the areas in which they have jurisdiction. These goals can be regulatory changes, meaning they need to make the change, or voluntary changes, which are changes by choice. Looking at this chart by Santa Monica, it includes reductions from state policies, such as increasing the amount of renewable electricity, but it also includes other reductions that were within the city's control, such as net zero emission buildings, such as increasing insulation and replacing natural gas furnaces with heat pumps, or sustainable mobility. This fits well with our own VWTS initiatives to track and measure greenhouse gas contributions to aid in our clients' sustainability initiatives. SWIP improvements were not a focus for greenhouse gas reductions, but it was focused on water self-sufficiency and coastal flooding preventions. However, at Veolia, we wanted to see the impacts this project could have on the greenhouse gas emissions also. VWTS is working on standardizing a tool to calculate and quantify the impacts that our systems have on our clients' greenhouse gas emission inventories. It is not the only tool to measure and judge the merits of a project, but it can help quantify the benefits. It also allows for a multi-view cost-benefit analysis instead of just economic metrics. Internally, we'd like to use it as a tool to look for opportunities to improve on future projects. We've come up with our own methodology, which allows us to find the net emission changes upon implementation of our solutions. And we've based this methodology using ISO 140604-2 as a guide. The first step in our methodology is to identify what we call the project case and base case scenarios, allowing us to quantify two emission scenarios and evaluate what changes upon project implementation. We then identify the scope for each case so that they are considered equal and identify all required inputs and outputs for each of these scopes. We then convert all of the inputs and outputs to tons of CO2 equivalencies using emission factor conversions from our internal database and external resources. Finally, we compare the two cases to determine if there are net positive or net negative changes and why this could be the case. So first, I will go over our Santa Monica analysis. You'll see this diagram that Alex showed previously, and basically we want to indicate that the city of Santa Monica relied on imported water from the MWD for their potable water. Importing water emits approximately 0.8 tons of CO2 equivalent per million liters, and the city currently uses around 10 billion liters per year. They want to plan on reducing their reliance on imported water because the availability is uncertain. You'll see in this next diagram that the exact distances that this water has to travel to get to the city of Santa Monica. The white arrow is the city of Santa Monica, and the black arrows are indicating where the California Aqueduct and the Colorado River Aqueduct begin or have to travel from. You'll then see with the base case, it is mainly focusing on the amount of imported water, and the Metropolitan Water District did a greenhouse gas emission analysis on their imported water, and this showed that electricity consumption contributes to about 85% of the greenhouse gas emissions. This can be through pumping the water or from treating the water. As renewable energy becomes more of a focus for the state of California, this emission factor is expected to decrease over time, but currently this is the emissions that we are working with. Now I'll go through the project case, which is what we've changed from, or what we will be implementing from instead of using the imported water from the base case. The new SWIP project is able to make advanced treated recycled water that can help replenish aquifers and be further treated for drinking water. Instead of receiving 1.5 mgd of imported water from the rivers, the SWIP allows for wastewater and surface water to be treated and utilized as non-potable water or to replenish the aquifer that feeds the potable water facility. All chemicals, electricity haulage, emissions, and etc. and more are considered for the new facility in comparison to the imported water. You'll see here our results from this analysis. The comparison shows that the project case does produce a higher greenhouse gas emission than the imported water case due to electricity usage and chemical usage. Most wastewater treatment facilities do not consider chemical consumption in their greenhouse gas calculations, which has created a source of error since the chemicals can be a significant emission portion as shown in the project case. Rejects from the treatment go to the wastewater treatment plant where they would have gone in the base case also, so this was considered not important. Next slide, please. So, fortunately, the city of Santa Monica uses the Clean Power Alliance, which allows them to run off 100% renewable electricity, bringing the electricity emissions to zero. This is a citywide program that was implemented to help with their greenhouse gas emissions. This shows that the city can now reach their goals of water independence while also achieving a similar greenhouse gas emission or less, depending on the chemical usage that would be used in the base case. Now I will be going over a food and beverage water reuse system. This is a pre-existing food and beverage plant that would like to plan for expansion. They have a basis of 2.2 million gallons per day of potable water usage. This produces a low strength, low solids wastewater that is currently hauled to lagoons and then land applied. They would like to expand their facility. However, they are not able to request more water to supply this new facility with water. So they needed to come up with a way to reuse their wastewater. So the base case is pretty straightforward. Basically, you take potable water, use it in their facility, and then it's land applied. The wastewater is land applied. Our project case allows for reuse of this water. Using an MBR and RO treatment, this reduces the waste volume and produces 1.7 mgd of potable water for reuse in the plant. So we are able to take the wastewater, treat it with our MBR RO, and recycle it to the front of the facility and only have a small portion of waste that will still be land applied, while this will allow for the plant to get their expansion. With this scenario, the greenhouse gas emissions showed a total reduction of around 6,900 CO2 equivalents per year, or about 40%. The emissions associated with the MBR RO treatment process was offset by the decrease in haulage requirement. As the solids from this facility will still be removed and land applied, the greenhouse gas emissions from this step is similar in both the project and base case. The biggest factor was that haulage of the wastewater was reduced by 6,500 tons per day, which has an associated greenhouse gas emission decrease of approximately 7,000 tons of CO2 equivalent per year. This grid is also 70% renewable energy, which has assisted with the greenhouse gas calculation. So this facility is now able to have their plant expansion while also having a significantly lower greenhouse gas emission. The last facility I would like to talk about is an anaerobic digestion facility. Currently, this municipality has around 60,000 tons per year of organics that are picked up in their garbage collection and sent to landfill. While there is some methane capture at the landfill, a lot still gets released to atmosphere. With methane having a 25 times global warming potential than that of CO2, this is creating a huge greenhouse gas emission. So the base case is currently receiving the source separated organics, sending it to landfill, and there's no further treatment other than some methane capture. AWTF's project case has designed an anaerobic digestion facility that will be able to treat the 60,000 tons per year of SSO through anaerobic digestion. This will break down the material to a digestate, which will be sent to a composting facility to get further treated. The biogas produced will be captured, treated, and upgraded to renewable natural gas and injected into the grid. Although this process uses more energy and chemicals, it avoids methane emissions, which should help reduce the greenhouse gas emissions significantly. So even with partial methane capture and venting, methane in the base case dominated the emissions profile. We had a reduction of over 66,000 tons of CO2 equivalent per year. We weren't able to determine the exact methane released from this specific landfill, but an average of the methane emissions for large landfills in this project's country and region were used for this analysis. This project case also benefited greatly from having the low carbon intensity from the renewable energy that is used in this municipality, which is around 95%. So you would be able to consider that a plant that wasn't using renewable electricity might look a lot different. Compost in the base case for other compost is the base case for other facilities, but not for this area, which did not previously compost SSO. Lastly, you will see that a big contributor to the project case is natural gas consumption. And this is because all RNG is being injected into the grid, and the facility will purchase gas from the grid due to government incentives for economic reasons. So as you can see, this municipality is now able to treat their SSO, reduce the amount that is being sent to landfills, and is able to receive money from injecting renewable natural gas into the grid and reducing their greenhouse gas emissions significantly. So for some key takeaways, as climate change is more prevalent in everyday life, change must happen. Both private and public sectors need to review their sustainability goals and ensure that they are doing the most to lower their individual impacts. There are many government incentives out there to help assist with these projects. A focus should be put on the evident local impacts that climate change is having. For example, with Santa Monica, a main issue being with water shortage, which would have a large impact on the community. Once these local impacts are identified, greenhouse gas emission calculations can help quantify what actions are the key issues and what potential improvements can be. For example, with the AD facility, the methane emissions were the key emission source and so needed to be the focal point. By using multiple factors when upgrading or designing a facility, such as local climate hazards, what greenhouse gas emissions are being produced, and economic incentives, a well-balanced project can be established to help reach your sustainability goals. Thank you for listening to our presentation, and we would be happy to take any questions.
Great, thank you. Big thank you to Alex and Leanna for sharing all that information with us. If anyone has any questions, you can pop them into the chat. Make sure that you send it to everyone or to all panelists to make sure that we can see them. Yeah, I think that was really interesting. It's interesting to think about greenhouse gas emissions as one driver amongst a series of many of them. So I guess the question that I've got, maybe we'll start with the question for Alex would be, it looks like right now the city is looking at doing indirect potable reuse with that water from the advanced water treatment facility. Has there been consideration for direct potable reuse when that becomes a more regulated available option in California, and how does that play into all of the different sustainability goals that the city has?
Yeah, absolutely. So the city is very interested in pursuing direct potable reuse. So for those who aren't familiar with the California regulations, California is expected to promulgate final regulations for direct potable reuse by the end of this year. So we're very eager to see what those rules say. But we are starting that conceptual planning to look at taking the water directly from the Sustainable Water Infrastructure Project, and rather than injecting it into the ground, pumping it directly to our KD water treatment plant as a raw water augmentation scenario. So from a high level concept, we've already identified that essentially skipping that additional step to pump it in the ground, pump it out of the ground, there's a lot of carbon footprint through electrical consumption that we can avoid. So from that perspective, it's advantageous to pursue direct potable reuse. And then just from an overall cost perspective, it's a lot cheaper to skip that step, and there's a lot of other drivers. But yeah, we're very excited to see how those rules shape up.
Great, thank you. I guess a question for Leanna. In terms of looking at the greenhouse gas emissions, it seems like in some of the cases it was a very obvious differential and benefit for the project case. And in some cases it was a little bit closer, dependent on a few other factors. Can you talk about how a project really needs to look at all of the different drivers to determine the right course of action for that specific project?
For sure. Yeah. So I think it's pretty evident in the greenhouse gas emissions what the goals were for the project that were stated. Now, for the water reuse project, their main goal was just to have a plant expansion, and by luck, it was also reducing greenhouse gas emissions. But with the Santa Monica, you could see that they were pretty close with the base case and project case, but the goal wasn't greenhouse gas emissions. It was for that water independence. So even with projects that, you know, could have a sustainability focus, if greenhouse gas emission calculations aren't involved in the design process, with wastewater treatment, there's a lot of electricity usage, chemical usage that does have a major impact. So using these calculations throughout a project or prior to and having that knowledge before design can help with these design aspects for lower greenhouse gas emissions. But it really depends on what the goals of the municipality or company is and what they want to focus on.
Great, thanks. Another question for Alex coming in. Does Santa Monica have any ability to use seawater for their water needs, or how does seawater options play into how the city is managing their potable water supply?
So seawater desal is definitely a possibility, but what we try to target is really the lowest hanging fruit first. And so if we have an available supply of wastewater that we can manage to then treat that up to potable standards, the emissions factor, the cost factor, the electricity consumption, all of that is significantly reduced when you're using potable reuse versus seawater desalination. But that being said, as the city continues to grow, you know, just for example, by 2029, we are required to construct an additional 9,000 affordable housing units. And after 2029, we're expected to get another increase, just like many other cities throughout California. So if we are going to continue to be required to install additional housing, absolutely seawater desal may be something we investigate a little bit further.
Great, thank you. There's another question about maybe for Leanna, but will other utilities be posting their greenhouse gas emissions like this so that others can do their own emission calculations? Can you speak a little bit about kind of what, at least in terms of what Veolia is doing with different utilities and industrial customers on this?
For sure. So not all MWGs have, or not all wastewater treatment facilities or water treatment facilities have completed greenhouse gas emissions, or it's not public information. A lot of effort is required to do these greenhouse gas emission calculations. And so when they do, it is typically public information, but it's not always for sure statement. So with this, when doing the calculations, we do use a lot, or we try to use local resources such as government information or government calculations that have been completed. But it's not always the case. So sometimes we have to just use a similar scenario or use our own database that has been established. So others can do their own emission calculations. Yeah, so there is a lot of public information available online also that allows you to do your own emission calculations. It may not be regional focus or local focus, so understanding what your electricity usage is it mainly renewable? Is it mainly non-renewable? Items like that has to be kind of a further research, but there are a lot of public resources that have been established for this reason.
Great, thank you. And I guess also, I mean, it's something that Veolia is doing with a number of different customers as well. So it's something that we're interested in working with our customers on if they're interested in doing this type of analysis, I think, as well. All right, so another question was about, as we speak, forest fire in North America is emitting a huge amount of CO2 and CO. I was thinking about that too, Leanne, as I look out to the smoky windows outside, when you're talking about some of the different drivers and climate change. And do you think that your efforts to lower gas emission will make sense compared to that? Was the question. So I can put that out to either of you. I know, Alex, you also live in a region that sees forest fires, and Is that something that the city of Santa Monica considers or thinks about in terms of the different sustainability actions? And if you have any thoughts about that.
Yeah, so it's a twofold. So it's adapting to the additional or the increase in probability of forest fires and the severity of those forest fires. So adapting the city's facilities to mitigate the hazards from those climate impacts. But the way I see it is that, yes, it is kind of a drop in the bucket compared to the huge amount that could happen from these natural disasters. At the same time, I think any opportunity that we can take to lower our emissions, no matter how small, is super critical when we look at all of these different facilities. They add up together to be a very large impact. So if we can do our part for our 1.5 MGD facility, we can only imagine what could be possible for, City of LA's 400 million gallon per day wastewater facility, or metropolitan water districts, very large water treatment facilities, and nationally and overall globally. So there's an opportunity there. I just hate to go into like, oh well, it's so bad here, why do we need to do something here, right?
Yeah, so I think all of the small steps do add up to be something significant in the end.
Yeah.
Thank you. All right, another question about the city of Santa Monica, Alex. This one will be for you. Is the city of Santa Monica used to working with innovative foreign companies in the area of wastewater treatment, or on other specific projects around water treatment, like pilot projects?
Yes. So we work with lots of different companies, so it's always open to different opportunities.
Great, thanks. Yeah, so it looks like there's lots of very innovative things the city's doing. So it's we're really happy to have you here speaking with us today and sharing some of that. So thank you. All right, that was all. If any other questions, feel free to pop them in the chat. Another question that I had for Leanna was about if N2O emissions were considered in terms of from the MBR application in particular, and how that was handled in the different analysis and comparison.
So N2O emissions for the MBR were not specifically accounted for in this. However, when looking at the comparison, our scope included an MBR, but the scope for water treatment with the MWD also considered or utilized aeration. So there would be N2O emissions in both cases. So this was considered, or this was not considered, or kind of considered nil.
Okay, that makes sense. Yeah, the water is being scalped, so it would have either been going through that treatment with the advanced treatment facility or at the Hyperion facility. So it kind of cancels each other out.
Exactly. Yeah.
Okay, cool. Thank you. Seeing if we've got anything else. All right, we've got another question here. So are direct and indirect potable reuse solutions that will likely be economically and environmentally feasible across the country and world, or do you foresee them being contained specifically in areas susceptible to drought? Maybe I'll point that to Alex first, because I know you're in one of those susceptible to drought areas, and then I might see if there's other thoughts afterwards.
Right. Yeah, I think the key focus is really on those areas that have water scarcity challenges, because potable reuse is wastewater is always there. So it's a low hanging fruit. That being said, I think there are opportunities in areas that are maybe a little bit more water abundant, and those drivers could be more environmentally focused in maybe not taking as much water as they need to from those maybe environmentally sensitive areas, and instead utilizing potable reuse opportunities. So there's definitely a lot of advantages to potable reuse, even in areas that don't have water scarcity challenges. So I do see this being rolled out globally, and potable reuse has been used for a long time, even in the fact of like in situ potable reuse, where you have your wastewater plant that's discharging to a river, and then the downstream water treatment is taking it out. So there's really nothing new in that side, but I do see this as being more like point source facilities that being distributed throughout. Yeah, that's definitely something that I foresee happening.
Great, thanks. And another region I think of is kind of the southeast of the United States, where in Florida, where there's kind of some of the reuse is being more driven by the discharge requirements and the new Senate bills coming into place that are banning any sort of non-beneficial discharge to surface water environment. So, like you said, I think the first driver we've really seen moving towards potable reuse is the drought, but I think there's a lot of other drivers that will factor in as well. And similar, I think Leanna talked about a project where the reuse driver was really the fact that they didn't have any other water to expand, just based on pipes, or some places don't have anywhere else to put the water. So I think there's a number of different drivers that will end up making it economically feasible in some of those other regions too. All right, so another question here was, can you talk a bit more about some of the water conservation measures that Santa Monica did to reduce that consumption? So that one would be for you, Alex.
Oh yeah, there's a whole lot of different activities, and a lot of these are actually driven by the Metropolitan Water District setting in some subsidy programs and conservation opportunities. So as a member agency ourselves of the Metropolitan Water District, we're able to utilize those subsidies and pass those on to our constituents. Some of them were actually more from the state-driven side. So we were required to produce an urban water management plan that identified the amount of water we have coming in and what our demand is and how to make up that shortfall. And as part of that, they also required a water conservation, I'm going to mess up the title of this. I'm just the water conservation plan. And that also identified if our urban water management plan said, hey, we have a shortfall, then what are the different steps that we would take in different tiers that could then make up that shortfall. And so with the drought that had been occurring for the last decade, essentially, we've been in this tier 2 reduction program. So essentially we're asking for that 20% reduction from our citizens. And a lot of that is really voluntary. So it's asking them to reduce based off of a posting that we put on their water bills. We also have a water wasters program. So if you see somebody that's discharging water onto the sidewalk, you can call a 311 number, and then we can take a look with them. One of the other big things that we incorporated, which is pretty unique, is actually a water neutrality ordinance, which said that all new development had to meet the same water consumption on that specific property as compared to 2015 usage. So in some opportunities, let's say it's a giant apartment building and now you're building a parking structure, you're fine. But the reverse is actually pretty impactful if you're building now a new high-rise over an existing parking lot. And so that created a lot of opportunities to receive additional funding for offset fees to then pay for low flow conversion projects, direct install programs. Yeah, there's so many different activities that it's really hard to put down on one exact water conservation measure that was hugely impactful. But you have to look at it, this whole portfolio of opportunities that then coalesce into your reduction saving measures.
Great, thank you. Kind of along the same lines as that other question, is that all the small things add up to significant change.
Yeah, totally.
All right, well, that pretty much brings us to the end of our 45 minutes here. So I just want to say a big thank you again to Alex and Leanna, our speakers, for their time and sharing their information and expertise with us today. We've got their contact information here, and I think the slides and video of this should be available, I think, within about the next 24 hours. So if you have any colleagues who missed this and want to check it out, feel free to point them in that direction. And yeah, just a big thanks to everyone for joining us today. I think it's great to learn about all the sustainability going on everywhere. And really, one of my big take homes, I think, today is about how there's lots of different drivers towards sustainability, and it's really important to think about how they all intersect and the balance between all of them. So yeah, thank you very much, everyone, for your time.
Great. Thanks, everybody. Appreciate it.
Thank you.
All right, thank you, everyone. That was great. Thank you so much to our presenters. Thank you to Veolia for being our sponsor. This actually concludes today's eShowcase. Thank you all for attending. The recording will be available at webcast.wef.org. We will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts.